Okay. Yeah, so we've got a nice photo there of Ross semi-boycotting elsewhere. We couldn't find a sober photo of him, so we've got a hedgehog there. But yeah, we thought we'd start everything off just by telling everyone what open data is, just so we're on the same page. So we took this from Wikipedia, just kind of be appropriate. And it just means data should be freely available to everyone to reuse and republish as they wish, without restrictions, copyright, patents, or other mechanisms. That's like a universally accepted definition.
So I think the key point is that you can't just put something up on the net and have it freely available. You've actually got to remove barriers that copyright imposes. You've actually got to make it open for reuse as well as just freely available. That's really, really important.
So we have like a few points about what you care about open data.
PDFs are not science. You should never, ever, ever put the data in a PDF. PDF is made to read, it's not made to reuse. Whenever I see all these journals putting their supplementary data in a PDF, I cry. It is the worst idea ever invented. The publishers are very, very lazy and they like the data available in PDF, but don't do it.
Has anyone ever tried to extract data from a PDF there before? Okay, yeah, well, those people, it's really, really difficult. And
half the graduates I know spend half their PhD just scraping data out of PDFs. It's really, really sad that we don't actually do it a better way.
Especially when you consider like you need data to like test one of the fundamental aspects. One of the fundamental aspects of science is reproducibility along with observation and experimentation. If your data is embedded in a PDF, you're not actually performing like one of those kind of things which define science. It's really bad practice. Don't do it. Kind of. Another great thing about open data is that if you make your data openly available, it's giving you the opportunity to be credited for all of the work which you're doing, all of your research outputs. So things like impact story these days, they measure like the metrics for your data as well as your stories and sort of your actual journal articles and everything. So it's just part of getting credit, not just for the papers. It's no longer just about having a PDF as a paper. It's about all of the outputs of your research and being able to get credit for that, being able to reuse them.
Yeah, and you should place public knowledge for personal gain. Anyway, next slide.
Yeah, next slide. Anyway, moving on. So I'm going to talk about PBDB. So I'm a paleontologist, and one of the fundamental core awesome bits of open data, which we've been using called the Palaeontology database. It's a completely community-driven project involving 386 scientists from around the world, and it's all community sourced. So people input data from papers, we extract it firsthand and input it into this database to liberate it from bloody tables, all the other nonsense which comes along with barrier-based publishing. And at the moment, we've got 53,000 papers which we've input the data from in there, which counts to 307,000 fossil taxonomic occurrences, 307,000 species, which entails about 1.2 million fossil occurrences from around the world. And one of the best things about all of this is that the data that's currently being entered into it is CC BY, so it conforms to standard open data. We actually, me and Ross, had words with the committee who lead PBDB, the database, and they changed it to that fairly recently, so good standard. And that's like big data for Telio, it's open data. And just to like visualize it, whew, this is every single one of those occurrences mapped onto the current globe. And as you see, there's a lot of fossil occurrences there. So we're talking about big open data. It's incredible, it's an incredible resource. And if any of you want to, you can go on it right now, click a button and get this up and start playing with it all the way on. This is like the data I use for my PhD. I'm telling you this, if you wanted to, you can go and do my PhD in about 5 minutes. It's really awesome. But there are some caveats with this. So like I mentioned, the licensing changed fairly recently to become default CC BY. So CC BY is a pretty good standard for data these days in research.
Well, CC0 not yeah. CC BY is people who are worried about not being credit.
Just needs to get attributed for it instead of no attribution. It actually still doesn't work either. So there have been a few kind of behind the scenes political issues which have transferred into tech issues, including like the cloning of the database pretty much overnight, which was not particularly legal. But as you can see, I don't know if you see well on the left, if you query both databases to extract exactly the same amount of data, this is Cretaceous dinosaur occurrences. If you query one database, you get 5,800 occurrences. If you query the current paleobiology database, you only get 225. So there's definitely some back-end problems going on there. So if you do want to use this, this is a bit of caution at the moment. People have attempted to automate like the input of data into it using text mining. I could go into it, but essentially it failed miserably through a complete lack of understanding of how papers work. And this was actually from the paleo community. It was very blind, very short-sighted. And also there's a general kind of lack of understanding, like, when you're crowdsourcing a database, magic fairies don't pop overnight and populate your database for you so that you can use them. this stuff requires time and effort. So while the PBDB in principle is a really good idea, the way people are using it is not necessarily the best idea unless you actually understand how it is built. So.
Yay, that's like now. So back in the past, let's say in the 1980s, academics didn't used to share data that much because it was actually quite difficult. The internet wasn't ubiquitous, and you had to post in snail mail these floppy disks and things like that. But nowadays, we don't have any excuse for that because even gigabytes or terabytes of data you can actually freely share on the internet. Companies and journals like GigaScience, no matter how big your data set is, they love making it available. So here's an example I've got of MRI scans of sea urchins. So this is an absolutely fantastic data resource, and it's 39 gigabytes. And if you submit, your big data to GigaScience, they absolutely love it. They find it a challenge. If you've got terabytes of research data, they would love to publish that for you. So there's except for very, very few rare cases, there's no such thing as too big to share these days. Next slide. Another point about why it's important to do open data is because, frankly, as a fellow scientist, I've read lots of papers, I've tried to reuse data from lots of papers. If you don't supply your data, I don't believe your results. Whenever I see a paper that doesn't actually supply the raw data, I'm extremely suspicious about it. I'll email the author for their data. There's lots of irreproducible science out there at the moment. There's a reproducibility crisis in science right now. People have tried to reproduce cancer research, about 42 studies, and they found they could only actually reproduce the results from about 10 of them, I think, which is terrible, really, really terrible. So basically, you've got to supply your data in order to show you've actually done the work, and that people can build on top of that work and go further with it. And next slide. But the opposite was also true. So if you do provide your data and you actually provide it with a bit of code and make it executable, make it easy to reuse, that's actually really, really impressive. Whenever I see that in a paper, if I'm a reviewer or a reader, I'll be like, wow, this person actually knows what they're doing. This person understands modern digital science and knows what we need to be doing in science to actually make progress in science. And so if you actually do provide your code, it's actually a big positive that you can get jobs and postdocs out of this.
One of the main reasons which I hear all the time about why people don't make their data open is because they seem to have this kind of sense of ownership over their data, that they need to make full use of it before they can release it to the world. So not only is that incredibly selfish, but it's also very counter to how science works. Science is all about collaboration, right? So by holding on to your data and not sharing it with your colleagues, you're actually slowing down the progress of science. So that's another kind of, let's just back that misconception out the window.
And so nowadays, there's new technology like IPython notebooks, which if you don't know about IPython notebooks, go and have a look at it. It's absolutely amazing. In the next few years, it's really going to transform science. And I want to see everyone's kind of supplementary materials as has an IPython notebook. It's a fantastic way of knitting together your code and your data and making it reproducible. And there's a thing in Nature recently about it. And it's not just for hipsters. It's really incredibly impressive when you see a paper. You can actually rerun the science that was performed, the computational science that was performed in the paper, all in one workbook. It's incredibly impressive. There's an example here from Titus Brown's lab. Titus Brown is a big hero of open science in America, where he published his paper in 2012, and the entire paper in computational bioinformatics is reproduced through the cells of the workbook. And you can see that what he says in the paper is actually true if you actually look at the data and look at the code. And it's really, really impressive. And this, I really think, is the future of science, the computational aspect. Obviously, if you're a wet lab scientist, perhaps your statistical figures, you can't do things like this. You can't do all the wet lab aspects like this. But for anything computational, you can stick in a workbook like that and reproduce and actually show that you get the numbers that you say you get. A friend of ours, Jurgen Triglav from Slovenia, has written this fantastic blog post recently, which we'd like to highlight, calling to attention the fact that all the figures in our papers these days are actually incredibly unstandardized. So I'm on a research project that's actually mining phylogenetic figures, evolutionary trees, and one of the main problems we're having is that there's basically no standards for display, and so the data is displayed in all these different forms, so we can't actually re-extract it. And it might be an idea in the future to actually look towards actually standardizing the way in which we represent data in our figures, or actually just do the simpler thing and provide the data, which would be a pretty obvious thing to do. I don't know why we don't do this already, but hey.
It's a 100-year-old conversation which needs to be reignited again. Yeah, despite all of this, open data is still a challenge. We're only just beginning to delve into the current state of these kind of things and what's possible. Open access has been a discussion now for about 25 years, but open data has only been much more recent. So, there's still much to develop before we go towards full reproducibility. So.
And if you've never seen our Open Science before, you should check them out. They're an absolutely fantastic group, mostly ecologists, working on tools for doing open science with open source software, which is R. I know many people in Imperial use R. Fantastic software, fantastic group, so check them out.
I thought this was just to troll him.
And so if you want to follow up on any of these discussions, I put a short link to it, because the long link is a bit long. Basically, there's a Google group, which all people from OpenCon in Washington have joined in, and we're trying to get everyone around the world to discuss how to do open science, how to do open access. So if you've got any questions, please go on Google Forum or tweet us. The hashtag for this meeting is OpenCon 2014. So, yeah, thank you.
We'll take any questions, I guess. We got time.
Plenty of time to ask some questions during coffee and the pub afterwards. Up next we have Eva. She's Outreach Director at F1000 Research, and she's going to talk a bit about open peer review and how it's helping as an educational resource. I'm just going to write a hashtag up here so that everyone has it.
Sounds about read that.
Yeah. Hopefully you can read that. Hashtag OpenCon 2014.
Okay, that goes through. Am I blocking the screen for anyone? I hope not. So, yeah, I work for F1000 Research, which is an open science journal in the life sciences. So most of what I'm going to tell you applies to life sciences. If you want similar examples for the more physical sciences, I'm just going to tell you before I forget, check out Copernicus publishers. They do very similar things, but they cover more physical sciences. So F1000 Research was launched in early 2013. And we don't just publish open access, we call it open science because it's broader than that. We also use open data, which Ross and Jon just talked about. So all of our articles include all the underlying data sets. But what I'm going to talk about now is our peer review model, and I'll show you later how it works exactly. But we created our peer review model to make publishing more comfortable and fun and interesting for both the authors and the reviewers of our articles. But as an interesting side effect, we accidentally created a really useful resource for people who are teaching students about peer review. And I gave the same talk last week at the Open Education Conference, which just like OpenCon was in Washington, D.C. There are 3 conferences going on at the same time. So I'll first start by telling you a little bit about why we should teach students about peer review. And then about the different peer review models, going from traditional peer review to open peer review. And then along the way, I'll show you how you can use open peer review in teaching, and I'll tell you what F1000 Research is doing exactly. So this is a quote from Ross Mounce. She is a faculty member at Monash University in Melbourne, and she says, "The term peer review journal is so familiar to scientists that it's often hard to imagine that the importance of the process is not immediately apparent to students." So as undergrad students coming in from high school, and even your first few years of your undergrad degree, you're learning from textbooks and you're not really aware of where that knowledge comes from. And then suddenly you're being asked to read papers, but you don't quite know what those are, and they're being printed out for you, or you send the digital PDF, and you don't really know how it works. So what Ross is doing in Melbourne, as well as in their campus in Malaysia, is she's teaching a course, Sci 2010, that's a mandatory course for all second-year undergraduate science students, so that's thousands of students. And they all learn about how science actually works behind the scenes. And one of the things she addresses is peer review. So she shows peer review examples to show students what it actually is, and she started out by showing her own peer review reports that she got on her papers, but she's now also using open peer review reports that she can just publicly find. Because the class is so enormous, she's actually also using peer review in the classroom, so students are reviewing each other's work before the faculty members assess the assignments. So it's basically they get to understand what peer review is from examples, and they get to try it out themselves on their classmates. So for undergraduate students, as well as graduate students, it's important to understand how peer review works because they read articles. But for graduate students, it's more than that. They also write articles, so they are receiving peer review, and very soon they will be asked to become peer reviewers. Now there's a very interesting article, you should definitely go and find this, by Virginia Walbert at Stanford. It's called "Are We Training Pit Bulls to Review Our Manuscripts?" And one quote in that article is, "Good early training of graduate students and postdocs needed to prevent them turning into future generations of manuscript savaging reviewers." And why are they becoming manuscript savaging reviewers? Because the comments they get on their own papers are really vicious and harsh, and they think that that is how you should do peer review. So how did peer review get to be so mean? This is my one slide, very quick history of peer review. The very first scientific journal, so this is a picture of the very first one from 1665. The first scientific journals were not peer reviewed in the sense that we know the word to mean now. They had editors, and editors looked at the papers, but they didn't send them out to peers in the field. That really started after the Second World War, so middle of the 20th century. And the reason that this practice started was that around that time, science really exploded. A lot more people started doing science, and fields became very, very specialized. So if you sent an article to a journal, there was a very good chance that the editors of the journal did not know enough about the paper. So they started sending it out to people who might know how it works. But they still had print journals, so they had a limited space. And with all these new scientists, there are lots more papers coming in, and they have to make a cut and decide which ones to publish and which ones not. So that's how peer reviews and journals sort of became gatekeepers of which science gets published and which not. And because your peers are usually your competitors working on the same things, comments can be a little bit mean because these people might actually have a stake in you not publishing the work. So I'm sure a lot of you know how this works. I put this slide in for my talk last week for educators, but this is a really brief diagram of the peer review process. This traditional peer review process, you send an article to a journal, then it goes through a closed peer review process where the reviewers know who the authors are, the authors do not know who the reviewers are. The article usually goes through several rounds of revisions, or many rounds if you're unlucky, and hopefully finally the journal will accept it and it will get published, or if you're unlucky you'll send it to another journal and start all over again. So as I hinted at, it doesn't always work very well, and this cartoon shows up in a lot of talks about peer review. Most scientists regarded the new streamlined peer review process as quite an improvement. People are not happy with peer review, so there have been a couple of solutions trying to make it more appropriate, basically. And one of these solutions that's really catching on is open peer review. So since the year 2000, a lot of journals have started some form of open peer review. Sometimes they just make the names of the reviewers public. Sometimes they show the review comments with or without names. Sometimes this is mandatory, sometimes this is optional. So all these different journals have different levels of open peer review, but they all have some form of openness. And again, you can see they're mostly in the life sciences at MUT. And what we do at F1000 Research, everything is open. You can see the names of the reviewers, and you can see all the comments that they made. I'm not going to go into too much of this list and the reasons why all these journals are using open peer review. I'm happy to discuss that later. I'd rather skip to the educational part. I do have a few examples of what open peer review looks like. So this is an example from B&J Open. Next to each article, there's a link to review history, and that pulls up a PDF document that has all the complete history of the paper in it, with names of editors, reviewers, and all the comments by the reviewers. This is another journal, eLife. They do it slightly differently. They also have a link in the sidebar that jumps to the bottom of the article, and here it shows the decision letter written by the editor. So it's not literally the comments by the reviewers, but it does contain the main comments, so he sort of summarizes it. And this is what we do at F1000 Research. So we don't just show all the review reports and the names. The article is also already online before peer review starts. So it's published after, it's already formatted, it's checked, the data are there, and then the peer review process starts. And as peer review reports come in, they're checked by the editors, and then they're published with the paper. So that means that you can see peer review as it happens. You can see an article go up, it will say awaiting peer review. Like this one, it's hard to see. This says awaiting peer review. And after a couple of weeks, peer review reports have come in, and now this box changed, and it has the reports. If this was actually the website, you could click these little icons, and it would take you to the actual reports. When an article goes through several rounds of revision, the box looks a bit more complicated, but it's the same idea. Everything is visible, everything is public, and if you click anything, it will take you to the report. So you can follow the whole trajectory of the paper. And this is what a report looks like. I know you can't read that. It has a name, affiliation, a short comment that you can expand, views, how to cite the referee report, and basically, and the author response as well. So everything, the whole peer review process is visible and public. So one of this is our same homepage that I had at the start of my slide. Because we have all these referee comments public, one thing that our editors can do is feature a referee comment on our weekly updated website. So we don't just have a featured article, we also have a featured referee report underneath. It's not necessarily from the same article. And they pick these referee reports based on how well they're written, how interesting they are. So the reports that they already pick would also be really good examples to use in a classroom when you're teaching students about peer review. So what we've done is we've set up an education page that's specifically meant for educators or graduate students. The first page is tips from researchers about how to write a good peer review report. You can see 3 on the screen. I think there's 8 in total. And the second page are actual examples selected by our editors of very well-written peer review reports, and they're selected by topic. So constructive feedback, or how to respond to authors who haven't made the changes you asked for, or how to politely say something really critical, or even how to leave comments if you really like the article, because you can do that too. Maybe you think it's amazing and you can say that. So there are lots of different examples on there. And we're currently working with a couple of organizations who are making use of this, and as of next year, there will be a couple of others. One of the things we do is we're one of the sponsors of the Sense About Science peer review workshops, and we try to attend and participate whenever we can. I don't know if you've heard of this, but Sense About Science runs about twice or thrice yearly workshops for graduate students and postdocs, where they have speakers, usually they're journal editors and researchers, who are talking about peer review, how to do it well, what the differences are between different types of peer review, and that they really make the participants of the workshop think about peer review for themselves. The other organization that we're working with at the moment is NYU in New York. The neuroscience department is planning to run a series of workshops for their graduate students, where they learn basically similar things, like how to do peer review, what is peer review. And what they're going to do is use the F1000 Research articles in their classroom to basically let students write their own peer review reports alongside the ones that are coming up on site. So the article goes up, it's awaiting peer review, and students can try to write their own report and then compare it with the actual reports as they come up. And that's something that you can only do with us because all the other journals that also use open review don't put it online until everything has passed review. So it's all, by the time the article goes online, all the reports are also there. But with our system, you can actually follow along and try it for yourself and see if your report matches the ones that are coming in. So we're still working out the details for this, but I plan to start the course in 2015 in the spring semester, so that's quite soon. And I did, in case any of you are interested in collaborating with us about something similar, this is basically what we're looking for. People who teach graduate students how to do peer review, people who teach undergraduates about peer review, or people who generally run workshops about open science or open peer review. And, oops, actually, sorry, the mouse is difficult. That's the link to the peer review tips page, so f1000research.com/peer reviewing tips. And that's my email address, or you can also tweet me at F1000 Research or at Eastern Blog. I didn't put on the slides, but I'm sure you can find it on the hashtag somewhere. Any questions? Yes, you go first.
So about peer review, you're talking about the negative aspects of it, like people being overly aggressive. But I'm wondering about the opposite, like people being extremely kind because it's friends of theirs or members of their labs. How can you show the relationship?
Okay, the question is about, so I mentioned at the beginning that people don't, one of the problems that people see with peer review is that it can be overly negative. As you mentioned, that there's also the opposite effect of it being overly friendly, where people are reviewing their friends. I think both. I know definitely that the Sense About Science workshop addresses that as well, and we don't specifically mention it on our page. We don't specifically mention the negative part either. We just show the tips on how to do it well. So that also means don't be too friendly. So in terms of reviewing friends' papers and people being overly friendly, that's something that open peer review can actually prevent against, because you do, as a reviewer, sign your name and you are held accountable for anything you write, whether that's overly negative or overly friendly and unnecessarily positive. So in both cases, signing it will really help people think about it, and both BMJ and Biomed Central have done a couple of studies that are actually looking at whether it has an effect, and they're really seeing that people who sign their names or who are asked to sign their name are thinking harder about what they're writing. Yes?
Do you get any sense that the population of reviewers who are willing to participate in open peer review is a specific population that, and that there's a mainstream which is not comfortable with it yet, or is it changing? Or?
So the question is whether we see that there is a specific population that is more comfortable with open peer review. We don't see it as much. When we invite people to review, the reason they say no is usually because they don't have time and because they can already see the article, and sometimes it's really long and the paragraphs are really long and they just say no because of that. In general, it does seem to be, overall, looking at all these fields, it is more popular in the life sciences, and Biomed Central only started open peer review on their medical journals and doesn't have it yet on all of their biology journals. So they saw that there was a difference between those two fields. And in general, I would say life sciences more so than other sciences. And within life sciences, there are fields where it's more popular. I think ecology, bioinformatics are more comfortable with it than others.
If I could just pitch in with Biology Direct at BMC has been doing open peer review for 7 years now.
Yeah.
And they've been going from strength to strength. And it's wonderful, as a young researcher myself, to read those open peer reviews. You learn more about how to do reviews and how to write a good review. And I don't know why it's not more common at more journals, to be honest. I think it's a great, great system, and I think it should be the norm rather than the exception.
Other journals that are currently doing closed review are looking at opening it up.
Yeah.
And I probably can't say which ones, but there will be more.
PHA does open reviews as well.
Yeah, they were on my list. Yes.
How do you get more scientists becoming a peer review for your journal?
So one thing that we're doing is, how do you get more scientists to become a reviewer for the journal? One thing we do is we allow people to co-review. So if you're, say, a postdoc and you've never reviewed before, and now you're being asked to do something where you sign your name, that can be a little bit scary. So we allow people to find another scientist, perhaps a more senior scientist, who is willing to co-sign their name to the report. So that brings people in, and then you have one report written by two people, and the next time each of them will be quite comfortable doing it separately, probably. The other thing we just do, we always make sure to invite 5 reviewers for each article. If it's summer or Christmas, they tend to, none of them might say yes, but usually that means that 2 of them will say yes. And that's a trick that a lot of journals use, that if you need reviewers, always invite many, many more than you actually need, because people are busy, and it is something that they do voluntarily, and that's something that all journals cope with, whether it's open review or not. Yes?
You're probably aware of Frontiers, the open access publisher. They have a journal for kids.
Yes.
Which is really, really interesting, where kids go and peer review and discuss, and they do probably a better job than adults. Very interesting. Just look, if you look up Frontier Journal for Kids, I think it's wonderful.
Yeah, so the comment was that Frontiers has a journal, I think it's called Neuroscience for Kids or something, or the Science for Kids. Young Minds, that's the one. Where children are peer reviewing work done by others. So it's the youngest peer reviewers in any journal you would probably find, and they're doing a very good job. And they're getting an early start. Any other questions? Yes?
I was wondering, in your system, is there a place for the author to respond to the comments people?
Yes. So the question is if there's a place for authors to respond. I rushed past it quickly, but oops. So this top thing is basically the review. It says continue reading. If you expand that, it's too long and you can't see the thing below it anymore. This box below, this gray box, is the author response. They don't have to respond. Sometimes they don't. Sometimes they respond just by sending in a revised version. But if they want to respond, they can just respond directly to that refereed comment, so you see it in context as well.
And all that is open, right?
Everything is open, yes.
Thanks, Eva. That was fantastic. We now have coffee and tea, and we also have an update on the Wi-Fi situation. Miriam?
So